Question 2, model answer. A dissected kidney. You should be happy with these structures. This is just AO1. You need to learn it and be able to regurgitate it. So we've got a capsule, sort of a skin around the outside, and then we've got cortex, then the medulla, then the pelvis, and then there'll be a couple of blood vessels that you might be able to see, but this one here is not a blood vessel. It's the tube going to the bladder, which is the ureter. So, regions of the kidney: medulla is A, and the one on the outside, the cortex, is D, so that's cortex. And B, that's the pelvis, or renal pelvis. And C is a tube, that's the ureter. So they have tricked you a little bit, they're not A, B, C, D going inwards. So keep an eye on that. All 4 will give you 3 marks, 3 will give you 2, 2 will give you 1, sorry. Now, on the outline above, draw the position of one nephron. Well, and then label the following structures. Well, on your diagrams that you have in your notes, you might have something that, glomerulus, the Bowman's capsule, proximal convoluted tubule, loop of Henle, distal convoluted tubule, collecting duct. And on there, you'll have a line, and this will be the cortex, this will be the medulla. So you need to put that diagram, apply that, this is AO2 stuff, onto this diagram. It's easier if you do it at the top here, because you can see where that line is. So you're going to have going down, doing a kind of mini version of it. Draw the position of one nephron, so it's going to go down, that sort of area. So most of the nephron is in the cortex. The loop of Henle and the collecting duct are going into the medulla. That diagram's probably a bit of rubbish, but don't have it touching the sides either. And this might not be quite big enough. However, that'll get you the mark. On your diagram, you're looking for Bowman's capsule, so that would be A, B, C, D. So on our diagram, so we've got A, B, C, D. And that will get us 2 marks. If you get 3 correct, you get 1 mark. 2 or 1, oh dear. But most people have done that fine. Here's an equation, and they're giving us lots of things to put in the equation and then an answer. In the Help Me video, I pointed out that really what we had to do here was put the numbers into the equation, work that out on the calculator, and then just change what we've got to make it into the right units that they want it in at the end. Some people have done this fine, some people have got 0. The reason for that is I've started mucking around with these numbers before putting them in and come up with some problems. Quite a few people have got 2 if they haven't spotted the change in units. And just a couple of people have got these 2 C's the wrong way around, or not checked the units or something like that. Okay, so let's put the numbers into the equation. So the equation is V of the filtrate equals V of the urine times by C of the urine divided by C of the filtrate. So that's what we're doing. We don't have to rearrange it. Sometimes they make you rearrange it. So V of the urine is there 1.3. C of the urine 2%. C of the filtrate 0.02. That's got me a mark. Okay, I'm 1 out of 3 so far. And then if I punch that into my calculator, I'm using my Noddy calculator this time, 1.3 times by 2 divided by 0.02 is 130. What's that unit? That's the volume of filtrate produced per minute in cm cubed. So that's cm cubed per minute. And it wants dm cubed per hour. So let's sort out the hour first. Equals 130 times by 60, so 60 minutes in an hour. Cm cubed per hour. So we times that by 60 equals 7800. That's now cm cubed per hour, but it wants dm cubed. So if you do chemistry, you work with dm cubed all the time, you'll be fine. Dm cubed equals litre. So 1 dm cubed equals 1000 cm cubed. And so we just need to divide that by 1000. So 7800 divided by 1000 dm cubed per hour. So divide that by 1000, 7.8. 7.8 dm cubed per hour. So 7.8 there. And the units are there, so that's okay. Part C. We have got a little bit of blurb, and it's the key bit of information it's telling us up here. So we're in the proximal convoluted tubule, so we know what happens. I'm now thinking of all the things that happen in the proximal convoluted tubule, and it tells us anyway, it tells us things are reabsorbed. And the key bit of information that we're going to need in part 2 is the water. So 70% of the water is being reabsorbed from the filtrate. And this is the tubular filtrate to plasma ratio. So it's mean how much is in the filtrate compared to the plasma. So 1 is equal. So that's after ultrafiltration, the liquid just going straight through. And so glucose and amino acids are disappearing from the filtrate into the plasma, whereas the urea, the concentration appears to be getting higher in the filtrate compared with the plasma. So explain why. So why the ratios for glucose and amino acids are decreasing. Well, straightforward. Glucose and amino acids are reabsorbed. And that gives you 1 mark, but we need 2. We need to somehow come up with more there. And it's reabsorbed, yes, but from where to where is the second answer. So from the filtrate to the plasma or into the blood. So not many people said the second mark there. Explain the changes in the ratio for urea. So there's two things that are going on. Now one is there's not much urea gets reabsorbed. So not much urea is reabsorbed, or you can say no urea is reabsorbed if you like, but some does get reabsorbed but not much. But why is it going up? So we'd expect it to stay at 1 really. That's this information at the top. 70% of the water is reabsorbed, so there's the same amount of urea but less water. So water is reabsorbed, so concentration of urea increases in the filtrate.